Welcome to a new video. In this video, we are going to do a data science project. We will do data analysis, feature engineering, and machine learning. I took this data set from Kaggle and I'm going to add its link to the description of this video so you can download it and try the codes by yourself. We have two CSV files in here, credit card and credit card label. So we are going to start by merging them. Okay, now we can start coding. We will start by importing the pandas. And then we are going to data reading for both of our datas. So firstly, let's read the credit card CSV. So we will say data pd read CSV and we will say credit card CSV. And let's check how it looks. Here it is. So I'm not going to talk about it, like talk about all the columns one by one, because firstly I want to merge the data frames. So I will use read CSV for the label. So I will say label is going to be equal to the pd.read.csv and we will say credit card label.csv, and let's check how our label looks like. Okay, our common column is individual ID in here and we are going to merge on this column. So what we'll do is we are going to reassign data like data.merge and we will say we are going to merge with label. Then we are going to say the common column is individual ID because it has the same name in the both, like you can check from here. Then we are going to say how is going to be equal to the left. So we are basically going to do a left join. Also we don't need to use capital letter, otherwise it will raise an error. And when we check our data frame's latest version, we are going to say we have the label now. Like in here we have the labels. So what these labels mean is you can also read about this data set from the Kaggle side. Like if the label is 0, that means that credit card application is approved. And if it is 1, it means that credit card is rejected. So we are going to work with a data set which we have information about credit card applicants and information about them, and we have the label of approval. Like we have the columns, like let's quickly check them: individual ID, gender, car owner, property owner, children, annual income, type of income, education, marital status, housing type, birthday count. Also, I'm not sure why this is negative: employed days, mobile phone, work phone, phone, email ID, type, occupation, family members, and label. Okay, let's also import data visualization libraries we are going to use. Let's import Seaborn and let's import Matplotlib, PyPlot as PLT. And now we can start to analyze our data. So let's start by displaying some of the rows we have. And we talked about the columns. We have both numeric and categorical columns in our data. We are not going to use all of them in our classification model, but I think we can use some of them. Okay, let's get general information about our data set using .info, like this. Actually, I need to write data. And from this code .info, we can get general information like the data types in the columns, non-null values, memory usage, and also you can see the summary data types in here. And for the numerical columns, you can use data.describe for getting the numerical summaries. And here it is. I'm not sure, but maybe this can be the days after the birth. Like we have all negative values in the birthday count, and in the employed days side, we have negatives and we also have positives. I think this is an outlier. Also, let's check others like, okay. So by the way, from the mean of the label column, we can see that the credit card applications are most likely to be approved since 0 was the approval. Great, let's check if we have any NA valued rows. So for that we will say data is NA and we will use sum in here. And here we have a lot. Actually, I'm not going to directly use drop NA method because when we do that, we are going to drop 488 columns. This is not a thing that I want because we can lose some really important information if we drop all this. So what I'm going to do is I'm firstly going to drop this column, Then I'm going to say drop NA, so we are just going to clean this amount of data. So for that we can do data.drop, and we will say columns is going to be equal to the type, and we will say occupation, and when we run this, our original data frame is not going to change, and you can see from data columns that we will still have the type occupation. Since we didn't assign this like data equals true, or we didn't do something like in place equals to true. Like if you want to modify the original data frame, you can just use in place equals to true. So in this way you are going to change the original data frame. Like when I run this right now, it's not going to be in here. And let's get the NA sums again. Like I'm just going to copy this and paste it in here, and you are going to see that when we drop NA values now, we are not going to drop out of columns and rows. So what we can do is we can just use data drop NA, and if we run like this, this is not going to modify the original data frame, so we will just do in place equals to true for modifying the original data frame. And when we say data is NA and we say sum, we are going to see that our rows which contains NA values are dropped. Okay, let's check for the duplicated values. For that we will say data.duplicated, and we will use .sum after that. And as we can see, we don't have any duplicated rows in our dataset. If we had, we can just use a method like drop duplicates from pandas, and it's a really efficient method that you can use. Also remember to use it with in place if you have any duplicate values in your dataset, but we are not going to use that. Okay, let's calculate the average income. So we can say average income, and we will do data annual income, and we will use mean aggregation function, and then we can just call average income. So from this we can say that the males in our data set is earning more than the females. So also we can sort this, like you can take this in here, and let's just quickly run this, and we can just do sort values. And what we can do in here, it's now sorted in the ascending order, and if we want to get this in descending order, we can say ascending equals to false, and now it's in the descending order. And let's say you just want to take this value, so you can just do 0 like this if you want, or if you don't want to take the value and get it with its index, you can just use head and put 0 in here. Actually not 0, we can just put 1 in here, and you will get the male in here. Okay, let's just remove this, and we are going to create a data visualization right now. Let's plot the average income by gender. So for that we will say SNS bar plot, and we will say X is going to be equal to gender income dot index, and Y is going to be equal to gender income dot values, and let's give it a title like average income by gender, and we will use plt.show. Here it is. Also you can add X label and Y label, like X label, let's say genders, and Y label, and let's say money. And when we run this, we are going to get our labels like this. Okay, let's calculate the value counts for label for seeing the improvement rate. So we can say label counts, and it's going to be equal to data label, and we will use value counts. And let's see what it looks like. Label counts. Here it is. So how we can make this information more meaningful is we can create a pie chart from this. Like we can say plt.pie, and we can just give label counts we created, and then for the label side we will say credit approved, and we will say credit rejected. And let's set auto PCT for seeing the percentages also. I'm just going to delete it after creating, and you are going to see the difference. We will say auto PCT, and we will say percentage 1.1 F percentage, and let's say plt.title, and let's give the title like credit approval status, and let's use plt.show again, and you are going to see the information like this right now. And if we remove this auto PCT in here, you are going to see that we are going to lose the percentages on there. So I'm adding it again, and you are going to see we have the 89% in here and 10% in here. Okay, let's do some group bys. Let's group our data by type income and calculate the mean of annual income. So we will say data.group by, and we will say type income, and we will say annual income, and we will use the mean aggregation function in here, and here it is. And let's group our data by marital status and find the maximum employed days. So for that we will say data group by, and we will say marital status, and we will get the maximum of the employed days. So we will say that maximum like this. Okay, let's group our data by housing type and calculate the sum of family members. So for that we will say data.group by, and we will say housing type, and we'll get the values of family members, and we will use that sum like this. Okay, let's group our data by gender and find the minimum birthday count. So for that we will say data group by, and we will say gender, we will take the values of birthday count, and we will take the minimum of this. Actually, I think these are negative and it's like nonsense, so let's just actually do like multiplied by -1, and let's just get them positive. Like, I'm not sure if these are the days after the birth. Like, if it is like this, then this age is like 7 maybe, not sure, but in that way it's not going to be meaningful since it's about credit cards. I'm not sure of this. Okay, let's group our data by property owner and calculate the average annual income. By the way, since this is non-meaningful for me, I'm not going to include this one in our models. So what we are going to do for grouping by the data property owner, we will say data group by, and we will say property owner. Actually, it has a name like this in the original data frame. We will say annual income.mean, and we will get it like this. Let's group our data by education and find the maximum mobile phone value. So for that we will say data group by, and we will say education. Actually, it has capital letters as I remember, and I will say mobile phone, and I will say that maximum like this. So I think it has values like binary. Let me quickly check, like data mobile phone, and we are going to see its values. Yes, I think it has binary values inside. So maximum is not meaningful. Actually, it only has one value. Okay, so even if we change this like minimum, we are going to get the ones. So okay, let's group our data by children and calculate the sum of annual income. So for that we will say data group by, and we will say children, and we will take the annual income, and also it will be our last group by. I don't want to make anymore. Okay, let's do some data visualization. Like, let's create 3 or 4 plots, then we can move into the feature engineering, and after that we can move into the machine learning part. So let's create a box plot of annual income grouped by marital status. So for that we will say sns.boxplot, and we will say x is going to be equal to the marital status, and y is going to be equal to the annual income, and we will say data is going to be equal to the data. And then let's give it a title like plt.title and annual income variation by marital status, and let's use plt.show like this, and here it is. let's create a violin plot of birthday count grouped by gender. So for that we will say SNS.violin plot, and we will say x is going to be equal to gender and y is going to be equal to the birthday count, and data is going to be equal to data. And we will say title distribution of birthday count by gender, and we will use plt.show in this one too. So here it is. Okay, let's create two more plots and then we can move on. Let's create a pie chart of the sum of family members grouped by marital status. So for that we will say data group by, and we will use marital status, and let's take the values of family members and let's say sum. Then we will say that plot kind is going to be equal to pi. Also, let's do the autopcity thing. For seeing the percentages, we will say percentage 1.1 f percentage. You are going to remember this as you do it. So, and then we are going to use plt.title. Then I will say family members distribution by marital status, and I will use plt.show, and here it is. Actually, sometimes when you create a pie chart from a group by operation, you are going to see that you will have an unnecessary y label. So how we can fix that is you can just say plt.y label, and you can insert an empty string in here, and you are going to see it's going to be removed in here. Great. Okay, let's create a final box plot of the annual income grouped by education and then move on. We will say data box plot column is going to be equal to the annual income. Actually, we need to capitalize the A, and we will say by education, and we will say plt.title annual income variation by education level, and we will use plt.show. Here it is. Okay, let's call our data and select some columns inside of it. So let's use, also we can write like data, we will use this, and we will get, actually we can get car owner, it can be meaningful. And then what we can get for our models is we can get property owner thing, and what we can get else is we can get annual income for sure. And then what we can get, let me quickly check what other columns we have. We can get education, and what else? I'm not going to take the others, like from here, and from here what we can get is maybe family members, but I'm not going to get that. We can get the label, it's going to be our target, so we need to get that. I'm going to make a final check, like if we can take anything else. I think no, it's enough. So let's reassign this as data. Also let's do a final check, like we are going to use these ones for the modeling side. Okay, so when we call data again, we are going to see our new columns. For training machine learning models, you can't directly use these values, like they are categorical and you need numerical values. So we will do encoding right now. I'm going to use label encoder, and let's do that. So for that I will import preprocessing from sklearn. Import preprocessing, and I'm going to initialize the label encoder like preprocessing dot label encoder. And now what I'm going to do is I'm going to say data, and I will say let's start by car owner is going to be equal to the label encoder. Here it is, dot fit transform, and we will use data car owner again, like this. Also we need to do this for the other columns we have, which are non-numeric, so we will do it for property owner from here. And we are going to do this for education too. So we will do, actually I didn't copy it, we will do it for the education. I'm just going to copy it from here, and when we run this and check our data frame again, we are going to see we all have numeric values. Right now we have different scales on numeric values, like this differs from others really much, and we are going to do scaling, but not right now, because if we do it before the train test split and we also scale the testing data, that will create a data leakage. So let's set our x and y. For the x we will say data.ilog, and we will not going to filter any rows, we are going to filter columns. We are going to take all of the columns instead of the last one. So for the y side we will say data.ilog, and this time we are again not going to take any rows, we will say -1. By the way, what I mean by we are not going to take any rows, we are not going to do a filtering based on rows, we are going to do a filtering based on columns. So with this code we will say we are going to take this for the x and take this for the y. Great. So now we can do train test split. I'm going to say from sklearn.model selection import train test split, and then I will say xtrain, xtest, ytrain, and ytest. Then I will do train test split x and y. Then we are going to set our test size as, let's say, 0.2, which means 20% of our data set is going to be in test set and 80% is going to be in the training set. So now what we can do is we can do scaling operation on our x. So how we can do that is we are going to say from sklearn.preprocessing import standard scaler. Then we are going to initialize this standard scaler, and for the next step we will say scaled xtrain. It's going to be scalar that fit transform, and we will use xtrain in here. And for the xtest side we are going to do the same, scalar that fit transform, and we will say xtest. Here it is. Great. So now before getting into the modeling side, I'm just going to define a function for getting the accuracy score when we pass in the predictions from the model. So with this we are not going to need to write it every time when we create models. So for that I'm going to say from sklearn.matrix, I'm going to import accuracy score. You can also use others. Each of them have different advantages, like I have a video named classification matrix. You can watch it for seeing the others like F1 score and rock curve, etc. So I will say define model performance, and we are going to give inside the predictions. Then we are going to print, when we call this accuracy score on model is, and let's use curly braces. Then we will say that format, and we will say accuracy score, we will say ytest and predictions. Here is our function for evaluating our models. Great, we can directly start with logistic regression. We will say from sklearn.linear model import logistic regression, and then we will say logistic model is going to be equal to logistic regression. We are going to initialize this, and then we are going to say logistic model that fit, and we will say scaled xtrain and ytrain. Here it is. So what we are going to do next is we are going to make predictions with our model, and let's do it like logistic predictions, and we will say logistic model, and let's use predict, and we are going to predict the values with scaled xtest, and let's get the model performance on this logistic model. Actually, predictions. Here it is. We have the accuracy score of 0.9, which means our model is great. This is a really good accuracy score. Okay, let's train other models and see how they perform. What I'm going to do at the first place is I'm going to import grid search, it's going to be helping us on the hyperparameter tuning. So I will say grid search cross-validation. What grid search does is it checks for multiple parameters and picks the best performing ones. So let's start to our models with k-neighbors classifier. So we will say from sklearn.neighbors import k-neighbors classifier, and we are going to define parameters grid. It's going to be a dictionary which will have the possible parameters inside. We will say number of neighbors. I think it will have 2 underscores, but I'm not sure. If it raises an error, we will quickly change that. We are going to say 3, 5, 7, 9 and 11. Also, you can extend these numbers if you want to get better performing models. Maybe it will change, maybe it will not, but you can try it out. Since I'm recording a video, I'm not going to try out of values. You can just extend these limits. Like you can also put 1 and 13 and you can extend these numbers like that. Okay, let's do weight, and we will say uniform and distance. Also, what we can do is, let's say algorithm. Actually, we need h in here, and we can say auto and kd3, and I think it's enough for the kn classifier. We will say grid kn, and we are going to do grid search cross-validation k neighbors classifier. Then we are going to do parameter grid, and let's set cross-validation as 2. You can also increase this number, but I want it to be trained fast, so I'm just going to go with 2. You can do like 5 or 10. I will say grid can.fit, and I will use xtrain. Actually, I'm going to use scaled xtrain, and we will use ytrain. And let's wait for it to fit. Actually, there's an error. Let me quickly check. And I think, okay, the 2 underscores thing is wrong. And when I change that, it's going to be fixed, I think. Here it is. By the way, by clicking this, you are going to see that our model in here. And if you do grid can best parameters, you will see the best performing parameters. Like for the algorithm side, auto, number of neighbors side 9, and for the weights, it's uniform. Okay, let's do some predictions with this. So we will say kn preds, and we are going to say grid kn.predict, and we'll use scaled xtrain for taking the predictions. And let's call our function model performance, and let's say kn preds. Actually, there's an error. Let me quickly check why it is. Actually, I think we made an error on, we are making predictions with the xtrain. So I'm just going to change this with test, and it's going to work smoothly. Here it is. Our logistic regression performed better. Okay, let's train a support vector classifier right now. So we will say from sklearn.svm import support vector classifier, and we are going to initialize this like svm is going to be equal to svc support vector classifier. Then we are going to say param grid svr, and we are going to do like, let's say c, and we are going to give the values for it like 0.01, 0.1, 0.5 and 1. And let's also define kernel, and for this we can say linear, RBF and poly. Actually, you can check the scikit documentation for seeing all the parameters and trying them out. I actually recommend that, because if you do that, you are going to remember all of them. So now I'm going to say grid svr, which is going to be equal to the grid search cross-validation, and I will say svm param grid svr. Actually, I need comma in there, and here it is. So actually we need to use this in here for it to work smoothly. And now what I'm going to do is I'm going to fit this in our data. I will say scaled xtrain and ytrain in here, and we got an error again. Actually, it's scaled capital letter X train, and now it's going to work smoothly. Okay, let's make predictions with this. So we will say predictions svc. We will say grid svc dot predict. Actually, I used like R, and we will say predict, and we are going to do scaled x test. Then we will call our function model performance and get this pred svc accuracy. Our accuracy score on the support vector classifier is 0.9, and I think it's really great. I'm not sure if it's better from the logistic regression, so let's check it. Actually, they are same. Okay, let's train a decision tree classifier model. So for that, we will say from sklearn.tree import decision tree classifier, and we will say parameters grid. We will say criterion, and for that we can say Gini or entropy, and what we can do is we can say splitter, and it can be best or random, and for the max depth we can say none, 10, 20, 30, 40, 50, and for the minimum sample split we can say 2, 5, 10, and for the minimum samples leave we can say 1, 2, and 4. And what we can do is we can just use grid search tree, and we can use grid search cross validation. Estimator is going to be decision tree classifier, and parameters grid is going to be equal to the parameters grid. Here it is. So in the next step we are going to fit this into our data. We will use grid search tree.fit, and we will use scaled x train and y train. By the way, before fitting this, I'm going to tell you a thing that in tree-based models like decision tree or random forest, you don't need to scale your data. Like, you can just remove the scale thing in here, but it has no harm, so I'm just going to do it like this. So we passed a lot of parameters inside, so let's just check the grid search tree dot best parameters, and here are our best parameters. Then what we are going to do is we will say predictions is going to be equal to the grid search tree dot predict scaled. Also in the test side you don't need to use the scaled values, because in the tree models you don't need that. We will say model performance, and we will get the predictions. It's 0.9. Go right. Actually, our logistic and the support vector machines model are the winners by far. Okay, let's train a random forest model. For that, I will say from sklearn.ensemble import random forest classifier. Then I will say random forest classifier model is going to be equal to the random forest classifier. I'm going to initialize this, and for the parameters grid side, I'm just going to define them outside right now. I will say number of estimators is going to be equal to the 32, 64, 128, and 256. And I will say maximum features is going to be 2, 3, 4. And I will say bootstrap is going to be true or false booleans. And for the OB score, I will say true and false. Okay, now we can define our parameters grid RFC. We will say, actually it's going to be much easier from others because we are defining outside of the dictionary. I will say number of estimators, and I will just use number of estimators we created. Then I will say maximum features, and I'm just going to use the maximum features we created. Also for the bootstrap, I'm going to do the same. I need to say bootstrap, and for the OB score, I'm going to do the same. You can also do it like this, and I will say grid and the first classifier. I will say grid search cross validation, and I will do RFC model and I will give the parameters grid RFC. And the next thing I'm going to do is I'm going to fit it to our data. Actually, I made a typo. I need underscore in here. And now I'm going to fit this like grid RFC.fit, and I will use the scaled X train. Actually, I'm telling you that again, this is a tree-based model and you don't need to scale your X, but I'm going to do that. And here it is. Okay, let's see the best performing parameters, like let's say grid RFC.best parameters. And for the bootstrap we have the true, for the maximum features we have 3, for the number of estimators 64, and all be scored true. Great. So what we can do now is we will say predictions RFC, and we will use grid RFC.predict, and we will say scaled X test. Actually, there's a problem. Grid underscore RFC. We need to do it like this. And I'm going to call our model results, model performance function, and I will say preds RFC. Actually, this is also 0.9. Okay. Let's apply some boosting methods. Actually, I'm going to train 2 last models, like I will use AdaBoost and XGBoost. Then I'm going to finish this video. So let's start with the AdaBoost. I will say from sklearn.ensemble import AdaBoost. Actually, this is also a tree-based model, so you can do it without scaling. I will initialize this, then I will say Ada parameter grid, and I will do number of estimators is going to be 50. Actually, I need to open a list, 50, 100, and 200. Then I will say learning rate, and I will say 0.01 and 0.1, then 1 and 10. And let's say Ada grid search, and we will say grid search cross validation. Then we will do Ada classifier, Ada parameters grid. Then let's set the cross validation as 2. And we are going to fit this right now into our data. Fit scaled. Actually, you don't need to use scaling again. Why train? And when it's trained, let's do some predictions with that. Ada pred is going to be equal to the Ada grid search.predict scaled X test, and let's get our model performance like Ada pred. Here it is. It performs same with logistic and support vector machines. Great. For the last step, we are going to train an XGBoost, and I want this to be winner, so I'm going to give a lot of parameters for this. And I'm going to do like from XGBoost import XGBoost classifier. Then I will say XGBoost classifier, and it's going to be initialized like this. Then let's define a parameters grid like XGBoost parameters grid, and we will say number of estimators. Let's give like 20, 40, 60, 80, 100, 500, 1000, 2000, and 5000. And let's give learning rates like 0.01 and 0.1, 0.2, 0.3, 0.5, 1, and actually it's enough. Let's also give 0.7 in here. And for the max depth, let's give max depth, let's give like 1, 3, 4, 5, 7. Actually, I missed 4 in here. 7 and 9. I think it's enough. Okay, I'm also going to set cross validation high this time. I will say XGBoost grid search, and I will call grid search cross validation. Then I will say XGBoost classifier, XGBoost parameters grid, and let's set cross validation as like 8. And let's fit this into our data. I will say XGBoost class grid search dot fit scaled x train and y train, and when it's trained I'm going to be right in here. So like there is 12 minutes past and it's not going to be finished soon, so I'm just going to remove some of these. Like I'm going to delete this one, I'm going to delete this one, I'm going to delete this also, I'm going to delete this one. Let's just forget about training a big model because it's not ending soon. So I'm just going to change the cross-validation as 3 and I'm going to rerun this. And I think now it's going to be trained much faster and we are going to get the results quicker. So I will say fit again and I'm going to be in here when it's trained. So here we have our model and let's say XGBoost predictions, and we will use XGBoost grid search to predict scaled x test. Also, before seeing its performance, let's just check the best performing parameters like best parameters, and here we have the 0.05 in learning rate, 4 in max depth, and 60 in the number of estimators. So let's get the model performance. For the last time for this video, we will say XGBoost predictions, and it's same with the logistic and the support vector machines. I'm not sure if it's going to change when we train this big model like with the 8 cross validation, but here we got a good result. This is a good accuracy score, and it was all for this video. I'm creating content about data science and programming. You can subscribe to my channel for more. I have a playlist of data science projects which I have more than 20 data science projects inside of it. You can just check it from my playlists on the channel, and I think you are going to benefit from it if you are learning data science, since there's a lot of projects where you can do practical exercises. Thanks for watching my video again and have a great day.